Dear students, I have come with a new module, weighted index numbers. That is Fischer's ideal index method. This is very important module and this you have to learn that. And we are going to do two problems in this module. If you know this basic computation, it's very simple computation. So if you see the introduction, Professor Fischer has given a formula for computing index numbers. So this is called as the ideal index. Professor Irving Fischer, that is this full name, and this formula is known as the ideal index number for computation, and this is the method we are always using for index computation. That is the importance of this module and the problems we are going to do. The formula is how you calculate square root of sigma p1 q0 divided by sigma p0 q0 into sigma p1 q1 divided by sigma p0 q1 into 100. So this method is known as the ideal method. Now this construction is based on geometric mean. We know that there are two methods, either arithmetic mean we can use or geometric mean we can use. But geometric mean is theoretically considered as the best average for computing index numbers. Now here you have to remember this is coming as a weighted index method. That meaning along with price we can see that Q0 or Q1. That meaning the quantity also is getting an importance. So this method is based on price as well as the quantity. That is why it's a weighted index method. So both current year and base year prices and quantities are used in the computation. That is the importance of this method. Now one more thing you have to remember, why it is called an ideal method. This Fischer's ideal index will satisfy both time reversal test and factor reversal test. And this method is free from all bias in the computation. Now we will do two problems as I told you. First problem we are going to do, construct the index number using Fischer's ideal method using the following information. So commodities A, B, C and D. 2020 price, that is 2, 5, 4 and 2. 2020 quantity 8, 10, 14 and 19. That meaning P0 and Q0 values are there. Now 2021, that is the current year, that price will be P1 and 2021 quantity will be Q1. So P1 values are 4, 6, 5 and 2. Q1 values are 6, 5, 10 and 13. Now I have explained P0 is the base year price, Q0 is the base year quantity, P1 is the current year price, Q1 is the current year quantity. So in our case, base year is 2020 and current year is 2021. Now we have to put the values in this table, that is P0, Q0, P1 and Q1. Now we have to multiply these values P1 Q0, P0 Q0, P1 Q1 and P0 Q1. Take the total of these values, that is 200, 160, 130 and 103. Now we have to substitute the values in the equation. You know that our equation is root of sigma P1 Q0 divided by sigma P0 Q0 into sigma P1 Q1 divided by sigma P0 Q1 into 100. We have to substitute the values in the equation, that is square root of 200 divided by 160 into 130 divided by 103 into 100. So you will get the index value as 125.605. Now we have to write the interpretation, that is prices increased by 25.605 or 61% in 2021 compared to 2020 for the commodities included in the index. This is how we will compare. So 2020, if these prices, if we are computed, the index would have been 100. Now 2021 when we are computing, the index is showing an increase of 25.61%. Now let us do the second problem, that is calculate Fischer's ideal index from the following data. Items A, B, C and D, base year quantity and base year price, that is Q0 and P0. Next year current year quantity, that is Q1 values and current year price P1 values. So these values are there, the columns in the solution, Q0 values are there, P0 values are there, Q1 values are there and P1 values are there. Now we have to multiply these values P1 Q0, P0 Q0, P1 Q1 and P0 Q1. So the total values are 127, 77, 179 and 104. Now we have to substitute the values in the equation, that is P01 is equal to square root of sigma Q1 P0, P1 Q0 divided by sigma P0 Q0 into sigma P1 Q1 divided by sigma P0 Q1 into 100. Now we have to substitute the values in the equation. We will get index is root of 127 divided by 77 into 179 divided by 104 into 100. So you will get the value as 168.4869. That meaning we have to write the interpretation: prices increased by 68.4869% in 2021 compared to that of 2020 for the commodities included in the index. That meaning if these commodities we have computed the index, 2020 index would have been 100, but in 2021 it is showing an increase of 68.4869%. So this is the importance of index. We can calculate the increase or decrease in the commodities, or whenever we are calculating an index, and we can use for comparison. And this is extensively used in taking business decisions, policy decisions, social science, research. And Fisher's ideal index is the appropriate method used for computation of index. So this is the importance of this module, and this is what I want to explain. Thank you.